Okay, folks, we're going to get started with our next session here, and I'd like to extend thanks to everyone here today, especially our speakers, especially our speakers that, like our next presenter here who's flown a great distance to join us. I'll introduce Ben Pruce from HashiCorp and let him give himself a more thorough introduction, but Ben, please take it away.
All right, so yeah, my name is Ben Pruce. I manage the threat detection and incident response team at HashiCorp. And today I thought it would be fun to give the little brother talk to Nabil's talk. He covered how do we do it at a massive scale, and I'm going to cover some concepts about how do you even get started with these types of things. So I think you'll see a lot of corollaries between our talks, but ultimately what I want to cover today is how Osquery played a role within HashiCorp for a small team attempting to move fast and tackle a very large scope. So let's see here. Did I do the things? No? There, we'll just do it that way. Perfect. All right, so anyways, today I want to talk a little bit about some of the challenges that we faced as HashiCorp was building up a lot of new capabilities, how we also needed to bootstrap our threat detection and incident response program, talk a little bit about the technical bits of how we got good visibility across the company, some of the tooling that we had to get in place so that we could collect that data, and then using all of that, put it together and look at how that's simplifying some of our detection needs today. So, cloud usage at HashiCorp. Starting back in about 2019, the company really went through a big transformation. We had all major cloud providers in scope. We had about 100 cloud accounts that were being used across AWS, GCP, and Azure. We had lots of different teams doing different things. Could be sales, support, engineering, R&D, security. We were all building and using these accounts. So lots of different needs that we were trying to serve. And then on top of it, HashiCorp was in the process of building out what is now called HCP, or the HashiCorp Cloud Platform. Compounding the issues, as a very young team, we didn't really have a vuln management approach today. We had lots of Wild West levels of image usage across the board, so many different versions of Ubuntu. We had Red Hat Linux, we had Windows, we had just all sorts of things happening. So on top of that, making it more complex, we had lots of different build patterns happening. So how people were actually building and deploying things wasn't very consistent at the company. So as you can imagine, lots of different challenges that we really had to come up against and work on solutions for. And so fast forwarding from 2019, where we had about 100 accounts, today we have drastically scaled up. We have about 30,000 accounts today and growing. So yeah, we have a account problem that we have to work through. So cool, pivoting a little bit to my team. Back in 2019, it was about 2.5 people focused on threat detection work. Very small, we had a very large scope. My team was responsible for security log data collection, detection engineering, both proactive and reactive detection, and then also building out automation and incident response capability. So fast forwarding to 2022, we have about 8 people now. And so as you can imagine, we had to make a huge bet on automation up front. We had to really rely on our capability to build things foundationally, expand those out to people, and let them use our tools. And so obviously with a small team trying to move fast with a very big scope, we needed to be very pragmatic about the way that we did our work. So we always try to bias towards action, but within that action, we always make sure we're cognizant of the reality that we may need to rip out and replace things. So we always focused on simple visions that can scale and give yourself space to evolve. And so lastly, touching on some of the guiding principles of my team, we really wanted to focus on extending kindness to the people that we worked with. Ultimately, working with engineering teams, they have things that they need to focus on, but there's security that needs to be met as well so that we can develop customer trust. So ultimately, we need to make sure that we extended the kindness of not giving them requirements, but offering solutions to them and let them focus on the things that they need to work on. So we needed visibility. They don't necessarily care about that from the perspective of security. But from that same sense, they do have needs they have to meet. So ultimately, we want them to have confidence that we're building the security piece for them, and they worry about the area they need to focus on. Cool. So one of the very first things that we worked on is called the Consistent Visibility Initiative. And so while partnering with our cloud security team, which was also small, it's 2 people around 2019, we started this process to build out a base image for all the teams. And that base image was very basic. It was effectively Osquery for visibility. We decided to use Fluent Bit for our log delivery, but then also baking in the capability so that these images are always fully patched and automatically available for every account so that people could use it. So with that, we also needed to have a scalable log collection platform. So we'll dive into a little bit of each of these pieces. Cool. So this is the one slide that I'm going to have a vendor pitch. If it bothers you, plug your ears. Feel free to tune out. That's okay with me. Ultimately, HashiCorp Packer is how we decided to build out our base image. I was able to do this over the weekend in like a couple of hours, rebuild our golden image process. Ultimately, it takes about 4.5 minutes for us to get that base layer ready and deployed out and shared with every team in the org. And like I said, this is shared out across 35,000 accounts. So we had to make it very basic. But yeah, touching here, I just have a little bit of code example showing some of the basic pieces of that Packer code, how we were able to share that out with the rest of the org. It's a beautiful thing. That's about the most you're going to get from me on the product side of pitching our company. But on the right-hand side, just kind of demonstrate if that's all you need is an image to work with. We have lots of different teams that are just kind of, they need an EC2 instance to work on. So they can actually take that in and using the power of Terraform, they can pull that data image in, spin it up, have it deployed in their account, and they can be using it in a couple of minutes. Cool. So touched a little bit on the base image, but ultimately we need to work on customer trust as well, right? Ultimately, we need to sell our products. We need to ensure that our customers trust what we're doing. And so we have things like compliance and patch management that we need to be concerned about too. So this touches on a little bit of our instance lifecycle approach. Internally, from a run the business perspective, we have a policy around max instance lifetime. So 30 days is the longest the instances are allowed to run. In our data plane, which is an abstract term that doesn't really mean anything to anyone except me here, our environments run somewhere between hours. About the max in our data plane is about 5 days. So we're constantly refreshing and rebuilding our instances. And so just touching a little bit on the vuln and patch management process, because of the investment upfront on tooling and being able to deliver fully patched instances, when we have a HiSev vulnerability that gets released, we can quickly use Osquery to dive in and figure out where the scope is for us. Because we have a lot of robust deployment tooling, we don't really need to do a full scope. We just need to confirm it exists somewhere. And then from that, we essentially go and rebuild, make that image available to everybody, and then give them a timetable of when they have to refresh. And so we've done this once, but we can actually refresh our entire environment in a matter of hours if we really need to. Cool. So we have an image. We have constantly refreshed, patched images available for everybody. We have Osquery baked in. We have some configs. We're sending data, but we need something to process all of that data. And so there's a lot of patterns for how people may decide that they want to ship that data. We made the decision early on that it was very important for us to collect the raw data, always have raw data available to us, because we thought that it was important that as a young team, needing to move fast, things will change. The products that we use, the vendors that we use, the tooling we use may need to be replaced at some point. So we've always biased on storing data in S3 first, fan that data out to wherever it needs to go. And so this is a high-level architecture of what our log pipeline looks like today. It essentially runs in 2 regions. It's an ALB, some auto-scaling groups. Fluent D is under the hood for handling routing, tagging, and sorting, as well as dropping data. And then essentially when buffers fill, we dump that data to S3. And so we made the choice within the storage mechanism that our buckets are a bucket per signal. And the reason for that was because it also makes it simplifies our approach for where we fan data out. So instead of having to worry about complex rules for parsing, which piece of the data in this bucket we pull out, we just say, here's an Osquery bucket, here's a Docker log bucket, et cetera, right? Here's a CloudTrail bucket. If we want it to go into another analytics platform, if we want it to go into our SIEM, like those are all things that we can trivially do. And as that data comes in, we can easily push that data out where it needs to go. Cool. Oh, and the other piece I wanted to touch on this, rehydration process. Anybody who's ever had to work with data that's expired out of your analytics platform and had to push that data back in for either a historical look back for an incident or something like that knows this can be an extremely painful process. For us, this is really straightforward. If we have a specific signal, because we also put all of our data in at date timestamp formats, we know exactly where to clue in on our data. We can easily push a year back if we need to. We can push a specific month within a year back in. But again, simplicity and easy to push data wherever we really need to. So the log pipeline today is ingesting about 1.5 terabytes a day. I have the signals listed up there that run through the log pipeline. The ones that are notably absent from this are all the AWS logs. That is because the our control plane lives in AWS for most of our tools. And so we decided to use the back channel because obviously pushing this data over the network has additional costs to us. So that data could be pushed out this way too. This pipeline has operated 3 years and I mean, it broke once. So, and that was our fault. So anyways, this is a very straightforward, simple pipeline. If anyone has interest in getting started with something like this, I have some starter code that could get you going. Yeah, so anyways, I can point you to that later. Cool. So I talked a little bit about the image process, how this helps us with having very short-lived instances and the collection process. But really putting all this together, what's important to my team is detection and response, right? And so this is simplifying all the decisions that we've made. This is simplifying our detection and response efforts. And I thought it would be fun to use a hypothetical attack on HashiCorp Cloud as an example for us looking at how we can investigate these things. So thinking about HashiCorp Cloud and an entry point, if we're gonna ignore phishing, which I get it, it's like 85% of how breaches happen, let's just say for a pure exploit, someone was trying to target HashiCorp Cloud Platform. Ideally, they would most likely either try and compromise a single customer to get into that data plane environment, or nothing stopping them from going and spinning up their own. So they could have an account on HashiCorp Cloud Platform and start poking around on it. At this point, they may be able to DOS the environment. They may be able to destroy that instance. But again, this is isolated to that account only. So destruction is pretty minimal at that point, right? You're really just hurting themselves or maybe a target customer. But we have thousands of customers. And so reality, they want to get into the control plane. That's where real damage is. That's where real good data is, et cetera, right? So ideally, the point is in this hypothetical attack scenario, somebody would want to try and figure out a path into that control plane. So let's assume that in this scenario, someone has some form of C2 available. There's probably many ways that you could go about doing this, but ultimately, again, you're just stuck in that account. You're trying to figure out how to get into the control plane. That's gonna take time, and so this is where an attacker, from their point of view, needs to find some form of privilege escalation, lateral movement, or more permanent persistence. They may need to do a lot of trial and error at this point. So they may be trying to do things like query the EC2 metadata endpoint, looking for any other form of SSRF internally. But the point is, at this point, they're maybe inside a piece, but they're not at the control plane, and so they're gonna have to do a lot of poking around. And so from our defender's point of view, we look at it, because we're constantly recycling our instances, we'll be disrupting that time that they have a fully established C2, which means they'll have to reestablish that C2. And every time our instance is refreshed, it'll break that format over and over again. So they'll have to keep reestablishing it. But the main point is, our instances, because we are patching our instances constantly, having folks rebuild and redeploy, trivial exploits should not really exist in the environment. I should say known trivial exploits. So again, they're gonna be continually reestablishing their C2, and essentially, just like any other good detection team, we're gonna have lots of tripwires. And ultimately, they really only need to hit one to trigger an investigation for us. And by every time forcing them to reestablish, they're just going to make more noise that's good noise for us to look into. Cool. So let's see here. From an investigation standpoint, a very simple detection case that we have is really just around surfacing outliers. So something very basic we can do with the cloud platform when it comes to a monitoring standpoint is surfacing outliers. For instance, why is a data plane instance running longer than 5 days? That's a very basic alert that we can put forward and get surfaced to us. So there's a couple of options of what that could be. It could be that we have a failed control plane operation. An attacker may have been able to actually prevent the shutdown event so that they could have a longer lived environment to play around with. It could just be a weird disturbance in the force, right? But the first possibility is very straightforward for us to rule out. We collect audit error logs, and this would actually be a control plane failed operation, so that would emit an error event. So it's easy for us to rule that first possibility out. The second one, we have Osquery, and we're collecting lots and lots of good data. And again, we have very short-lived instances, so the look-back period is extremely small. So for us to populate the entire set of commands that were run on any given instance is like seconds. So someone, an analyst investigating this, we don't even have to worry about aggregation. You could look at the list of commands that were run on an instance that's lived for 5 days, right? It's very easy for us to comb through that data. And so, at this point, maybe the attacker, we were able to see some weird things that they were doing that broke our current deployment and lifecycle model. And then on the third, hey, maybe it's just a disturbance in the force. Computer's got to compute. So we'll just blame DNS, call it a day, move on. But the reality is the same strategy can be applied to any short-lived infrastructure. And so I thought it'd be fun to bring a very interesting example, GitHub Actions self-hosted runners. Newer thing that's been out, released by GitHub. We can do the same thing though. We have max lifetimes set around our GitHub runners. We have a very good profile of how long those run in our environment. And so we can get an alert for a self-hosted runner that's running longer than what the expected max lifetime is. So by looking at the process events table in Osquery, we can really quickly start to surface information. And this is an instance that runs maybe an hour max, right? So imagine the data set. It's extremely small for us. But looking at this as this example, you can see here, I don't know if it's really easy to read or not, but what's happening here is you can see a process is curling to a suspicious domain, which I had to white out. So let's say it's hacker domain, okay? And that curl is actually writing something to a file. That file is then made executable, right? So in the process of our investigation, we would go down and maybe using file carving with Osquery, we can pull that data back to us and start inspecting. And then by looking at this file, we see in this scenario that someone was able to use a basic privilege escalation, and then a very weird thing where it turns out restarting the GitHub Actions self-hosted runner breaks the configuration, and that instance just lives. So very weird behavior, can't fully explain, but at this point, we would run our typical IR process here and figure out full root cause and move forward from that. Cool. So to wrap up, making Osquery and log delivery available to everyone internally increases our adoption speed. We are solving some of the security base image needs for folks so they don't have to worry about it. They just know reference the latest image that we have built and available to them, and they'll be in good shape, right? This also makes it easy for us to identify non-compliant resources. Obviously, we give people a lot of freedom to run in their accounts and do the things they need to, but we do robust tooling around config management. So we can use our config management and compare to actual live resources and see pretty quickly if people are not using the base image. And at that point, it's just education and helping people get into a compliant state. Simple scalable log collection and long-term storage. By using a very straightforward pattern, you always have your data available to you. You can move that data. You can negotiate maybe a little bit harder with your vendors if you feel like you're not getting what you want. But ultimately, you can walk away too, and you don't have to worry about things like, oh, this vendor has our data and we have a 365-day compliance issue we have to worry about. So now we have to extend our contract longer. This gives you a lot more freedom to make those decisions, to move fast, and walk away from things that aren't helping you and focus on the tools that do. Cool. And then last thing is just around keeping your instance TTL extremely low and doing lots of routine redeploys really encourages ephemerality in your environment. We have a strong philosophy around changes really shouldn't be made on your hosts. Instead, you should look at deploying and rebuilding. When you need to make changes, deploy and rebuild. And so that pushes people to focus on really robust tooling for how they manage and deploy their images. This also reduces some of that burden on the vuln and patch management process. And then from the perspective of TDR, my team, this makes it much easier for us to do analytics and dive in and investigate and run our incidents. So with that, I would like to open it to questions.
You said the log pipeline broke one time. Was that you?
That's not fair. It actually wasn't us. It was a very weird thing in a development environment. Someone left something over the weekend and it just absolutely crushed everything. I mean, we're talking hundreds of millions of error events trying to go through this pipeline. So it was a weird thing and we were able to address it. So hopefully it never happens again.
So one problem that we haven't really fully solved is like, how do you handle failures in the Osquery agents that you've deployed? Like, how do you know your coverage and like, you know, this notion of like who watches the watchers?
Yeah.
And so in our environment, we just kind of don't care.
Yeah.
But you know, as a security practitioner, that makes me feel not great about my job. So I'm curious, like how do you solve the problem of coverage and knowing that you actually have the base image in all the places that you want it to, and that Osquery is actually functioning and doing its job in those?
Yeah, I mean, it's a great question. And to be honest, we don't have a great answer today. I think it comes back to the idea of how we work with our config management database and what's expected to be there and doing comparisons on what data we're collecting.
But you actively are looking at that?
So we do in some circumstances. We don't have like a full scale visibility on it. I mean, it is, as you can imagine, a challenging thing to tackle. So yeah. I wish someone would solve that for all of us.
You just need another agent.
I like the way you think.
You said you let people like deploy images and just like try to educate people to deploy a base image. You don't find a little 5-minute Lambda function to like shut down anything that isn't kind of what you expect?
Well, I mean,
education?
yeah, I mean, so I think if I understand the question is, do we use Lambda and how do we monitor that stuff?
I guess you find education better than just like a brute force kind of shut stuff down that you don't find in compliance?
Oh, so you're talking about images, say, if somebody didn't use the base image. Right. Yeah, so it is a lot of education, and it's like most things, right? It depends. It's going to be a risk-based approach. If it's a dev environment, we might shut it down and encourage people to use the tooling that we made available to them. It really depends. But ultimately, you know, when it comes to prod, everyone's building off of the base image there, so it's not really a problem that we have to deal with. Yeah.
Hi, thank you so much for such a wonderful presentation. I just wanted to ask, how does your SRE team feel about the whole rebuild when you need to make changes versus making them directly on the hosts? And then the second part of that question is, how do you feel about read-only file systems?
Wow, okay. I have a good answer for the first one and a bad answer for the second one. So how does the SRE, the question was, how does SRE, oh wait, you heard it, microphone, gosh. I think they're fine with it. I mean, they're doing it already too. We're just a step in front of them in terms of giving them something to build off of. So, you know, obviously HashiCorp has Packer, Terraform, you know, all these tools for deployment stuff. They're gonna use them too. All we're saying is before you do that, use our image. So do the things you need to do and build on top of it. But going back to the point about the robust deployment tooling, that's what we really spend a lot of time on. And we don't have an opinion for how they decide to deploy. All we ask is use us as your base layer in the foundation of what you're building on. And then how do I feel about read-only file systems? I don't have an opinion, I guess.
Hi, Ben. I had a question which is a little bit selfish on how do you store and modify your detection rules?
Yeah, so super outside of the scope of the talk, but
I can find you later.
No, it's okay. I'm happy to talk about it. So our data today, we push into Sumo Logic. That's what we use effectively for our rules. We have another repo. It's a tool that we wrote internally that just manages the code deployment. So, and it's backed by Terraform because it has to be. We do detection as code. That's correct.
What kind of tooling do you use to do the vulnerability management on those base images or the images that other teams create on top of the base images before deployment?
Yeah, so we don't have a tool. We do manual investigation on those things today. Really, HashiCorp is considerably a young team when you think about the cloud platform and where the company is today versus 3 years ago when I joined. We didn't have a cloud platform, so even the security team didn't really exist in the same way that it does today. So those are areas that we're continually looking to build out and improve upon. A lot of our focus is saying, hey, a lot of the stuff, if it's patchable, it should just be built on a weekly patched instance. And so a lot of those problems we just don't necessarily deal with. When things emergency come out, the log4js and stuff like that, we jump in and we basically manually investigate. We do some confirmation based on the data that we have today, very similar to what Netflix has to do. We take the data that we've got. And for us, because we have the deployment tooling in place, it's pretty trivial to just say, we'll worry about whether we're compromised in a different bucket of focus. Today, let's just fix the issue. And so we can just push people out and say, hey, redeploy, you've got to rebuild.
Are folks using, on your team, using Osquery for deeper introspection or live querying, threat hunting?
So we also are not doing any sort of live querying today. We do have Osquery on our endpoints. That was a recent project. So from the user endpoint perspective, we have Fleet, and so we have that capability in that space. My team is mostly focused around the production workloads in the cloud environments. So yeah, it's something that we've considered. It's just kind of balancing needs and priorities.
Hey, great presentation. Thank you so much. I had a question actually around the response side. So I loved your term good noise for all of the data that you're getting for detections. And I was kind of curious about, it sounds like a very manual process for carving your files and going through everything right now. And I'm curious if you're looking at kind of read and write to kind of respond to this stuff, or just curious about the response side for the scale that you have.
Yeah, so I debated how much to bring into the response architecture. We actually, as a small team, have invested heavily in automation up front. My goal has always been to try to not build a SOC. So we've taken that approach of you should automate as much as you can because paying someone to look this stuff up is like a waste of human time. So we do tons of enrichment up front in our response process. We have highly customized tickets that we use for tracking. And those are things that, so when someone on my team has to investigate a given alert, by the time that they actually get notified to look into something, we've already pulled across our asset management database. We've done and set some seed queries up for them. And all of these things just help them essentially look and triage the alerts so that within a minute to 2 minutes of looking at a given ticket, they can decide whether or not to continue to prioritize that. or if it's just something to look at down the line. So yeah, I think the short answer is lots of automation. Yeah.
I have sort of a specific question about how you're doing correlation. You're baking the base image, and that's being deployed every so often. And presumably, you're doing something with UUIDs when images spin up or get deployed for Osquery. How are you correlating that with like asset buckets, or these are running this service, these are running that service? How do you know which hosts to go investigate, basically?
So, are you talking about just identification from a given alert?
Yeah,
Okay.
basically.
Yeah, so I think if we're talking about just at the host layer types of alerts, I mean, essentially we have an instance ID, and that's enough for us to start working from. I think it gets a little bit more complex when you start looking at like microservice level investigations, app layer type investigations. We have some other systems available to us to kind of tie that data together. Admittedly, it's still pretty manual when it starts to come to sort of the app layer stuff. But from the host layer stuff, I kind of showed back in a few slides ago, we have this Osquery host dashboard. That is something you can go and drop an instance ID in, and it immediately starts telling you everything about that instance. And it's all just the Osquery data. So telling us what changes have happened on the system, what processes are running, listening ports, socket connections, like all of that data is quickly available to you. And all of it's kind of like, again, seed queries. So you can click on that, open it up, and start digging in a little bit further.
And that dashboard is something you wrote in-house?
That dashboard is actually something I made on top of Sumo Logic. Yeah.
Thank you.
All right. Ben, thank you very much. Quality security presentations make me really hungry, and so we've just rolled out lunch. We're going to go for another break. Please continue networking, grab some sunshine, and we'll meet back in a bit. Again, thank you, Ben.